Another two-dimensional motion that we are going to study for today is uniform circular motion. A car moving of circular track with constant radius at constant speed, a communicating satellite orbiting the Earth and a skater in a circle with constant speed are some examples of this type of motion. Uniform circular motion is a type of motion when a body moves in circular path with constant speed v, that is, the magnitude of the velocity is not changing. However, in order for a body to turn around the circular path, the direction of this velocity is continuously changing. This change in direction corresponds to acceleration called centripetal acceleration A sub c, that compels the body from straight line motion into circular motion. In next section, we will discuss the kinematic quantities and equations for this type of motion. Now I will discuss to you the kinematic quantities and equations for uniform circular motion. Imagine a car moving at constant speed on a circular track of radius r. We call this speed as linear speed, denoted by letter v. It is the distance traveled by the body in one revolution along the circular path in a given period of time t. This is also the magnitude of instantaneous velocity of the body, provided that the motion remains uniform. For this reason, we use the letter v instead of s for the linear speed. The distance traveled by an object to complete one revolution along a circular path with radius r is equal to the circumference of that circle 2 pi r, and the time it takes to make one revolution is called the period t, hence linear speed v is expressed as 2 pi r divided by t. Although the magnitude of the linear velocity is not changing, its direction is continuously changing as the object turns around the circular path. This change in direction of the linear velocity corresponds to an acceleration called centripetal acceleration, or sometimes it is called radial acceleration. Centripetal acceleration, denoted by a sub c, is the instantaneous acceleration that compels a body to move around a circular path. The word centripetal means seeking the center. Therefore, the direction of centripetal acceleration is always towards the center of rotation. Centripetal acceleration can be computed by dividing the square of linear speed v by the radius of the circular path. Another formula can be derived by substituting 2 pi r over t to v, so centripetal acceleration is also equal to 4 pi squared times r divided by the square of the period t. Wow! We've gone this far. This is the last problem I'm going to explain for this unit. Problem number 14. In a carnival ride, the passengers travel at constant speed in a circular path of radius 5 meters. They make one complete revolution in 4 seconds. Letter A, what is the linear speed of this ride? Letter B, what is their acceleration? As mentioned in the problem, the radius r is 5 meters and the period t is 4 seconds. Required quantities are linear speed v and centripetal acceleration a sub c. So here's the solution. For linear speed v, using the formula 2 pi r divided by period t, so the linear speed of this carnival ride is 7.85 meters per second. For centripetal acceleration, that is 4 pi squared r divided by t squared. Substituting the values will give an acceleration of 12.3 meters per second squared. Now, give a meaning to these quantities. Maybe you are thinking, what causes dizziness when you are on any carnival ride? One easy way is to compare the centripetal acceleration to value of gravitational acceleration, which is 9.8 meters per second squared. Since our answer, 12.3 meters per second squared, is greater than g, therefore we can presume that this ride is a dizzy one. More frightening than you are falling due to gravity. Congratulations! You made it to the last exercise for this unit. You better keep up. Exercise number 8. A Ferris wheel with radius 14 meters is turning about a horizontal axis through its center. The linear speed of a passenger on the rim is constant and equal to 8 meters per second. Letter A, what is the passenger's centripetal acceleration? Letter B, how much time does it take to make 10 complete revolutions?